Today we are going to take a look at how we simplify radicals when there are variables included. So the first three problems that we have at the top of our paper are review from yesterday. So it might be a good idea for you to kind of hit pause and work those out on your own and see how you do, and then hit play on the video and sort of briefly watch and make sure that you're getting those answers correct. So if you're checking here, right, on our first one, you could sort of divide by whatever you want to divide by, but I am going to pick 5 to start with. Okay, so when I get to this point, sorry, I'm struggling with my camera, right, we're finding our pairs. So we have a 3, 3, a 5, a 5. And all we're left with is 15. There's nothing left on the inside, so our answer is just 15. Number 2, again, you can divide by whatever you want. We get a 2, a 3, and a 5. So we have a pair of 3s, and we will get 3 square root 10. Number 3 is much larger. See, so 1, 2, 3 3s, 1, 2, 3, 4 2s, oh, 5 2s, and a 5. So I have 2 times 2, which is 4, 4 times 3, which is 12, square root 30. Okay, then we have prime factoring. So we've already talked about this. This is review as well. But just as a reminder, right, when we are prime factoring with variables, we start by prime factoring the coefficient. So I'm going to prime factor 20 just like we have been. So we'll get a 2, and a 5. And then to prime factor that variable, we write it down as many times as the exponent tells us to. So if we have a to the 3rd power, we're going to put a times a times a. And b squared tells us 2b. So this prime factors into 2 times 5 times a times a times a times b times b. Okay, so if we want 5w to the 7th, 5 is already prime, right? I can't split 5 up anymore, so I just have 5 and then 7 w's. That starts to get a little bit annoying to write them all, but that is what we would do. 48. Okay, so if we start going here, maybe 4 and 12, 2 and 2, 2 and 6, 2 and 3. So 1, 2, 3, 4 2s, a 3, and then x to the 4th power is going to stay 4 x's, and then 2 y's. So the reason why I wanted to review that is because if we can prime factor and a variable is included, our steps are generally going to be exactly the same as what we saw before. Okay, so when we're looking at these today and we want to simplify something that's underneath the square root that now includes variables, we are still going to start with that exact same step. So our first step is still going to be to prime factor. We just now know that when we want to prime factor with those variables, right, we're starting with the coefficient. A 2 and a 9, right, whatever numbers you so choose to pick. So we'll get a 2, a 3, and then 5 a's and 2 b's, right? So I really, truly still have all of this underneath the square root. Our second step is then going to be to identify any pairs. So we're going to circle our pairs. And just like we said before, right, those pairs that we're circling are anything that would be a perfect square. So if this was a cube root, we'd do 3 of them or whatever, right? But we're doing pairs because it's a square root. Right, and those are all the pairs that I'm finding. Okay, we then know that we want to take all of our stuff that we're circling and we're going to pull that out in front. right? We're putting that circled stuff, for lack of a better word right now. There are fancy words and radicans and all that stuff. But remember, each pair counts as one item. So even though I'm circling 2 3s, I'm only counting it one time. So I'm going to bring 1 3 out in front, an A out in front, another A out in front, and a B out in front, right? Anything that's in the same place is getting multiplied. And underneath the square root, I'm putting all of my stuff that did not have a pair. Right? If there's no pair, it stays underneath the square root. So I have a 2 that stays under, and I have an A that stays under, and anything that's in the same place gets multiplied. So our rule for exponents, right, when we're multiplying with exponents, we really truly add the exponents. So this is really a to the first times a to the first. So that's a 3a squared b square root 2a. Okay, so we're just going to go through and look at some of these and make sure we feel comfortable with how to do these. So if we look at these examples over here, number 1, we're just going to again start by prime factoring. And sort of right here off the bat, we take this 38 and we go, uh-oh, I don't see a pair there. Okay, but don't give up because remember, we're not fully prime factored yet. So we really need 2 times 19 times x times x times x. Okay, so we have a pair of x's. So that x comes out in front. The 2, the 19, and the x stay inside. So we'll have x square root 38x. Number 2, here's when we have to be a little bit more committed. Some of you might see this quicker than others, okay, but 121 doesn't have a lot of things that it's divisible by. In fact, the only thing that you're gonna find is 11, so you really kind of have to stick it out to find that set. So we'll have 11 times C times C times C times C, and we're looking for any pairs, right? This is really truly all still inside the square root. And anything that has a pair is coming out in front. So an 11's coming out in front, a C is coming out in front, another C is coming out in front, and that's everything. There's nothing left for inside the square root, so there's nothing left for us to do other than to multiply those things, and we will get 11C squared. Okay, we will then look at number 3. So we have 180, D to the 6th, G to the 3rd. Again, you might choose different numbers to start prime factoring with. As long as you don't make any math errors, your final answer should be the same. So we should get a 2, a 2, a 3, a 3, a 5, and then we have 6 Ds and 3 Gs. Squeeze that one in there. So we have a 2 and a 3, so a 2 times a 3 gives us 6 that comes out in front. A D times a D times a D, which will give us a D to the 3rd, and a G that are coming out in front. And left over inside, we have a 5 and a G. Now we might look at example 4 and you might go, holy cow, do you want me to write down 38s? Well, the answer to that is no. I don't want you to write down 38s. I guess if you needed to write down 30As, you could write down 30As. Okay, but if we really think this through, I hope that we would realize, for example, on number 3, when we wrote out 6 Ds, we found 3 pairs. Because pairs is the same idea as dividing by 2, which means when you have really large numbers inside your square root, okay, so we have an A to the 30th and a B to the 25th. So you have really large numbers inside your square root. Instead of writing that A out 30 times, you can really divide the exponent by 2. Right? That's the same thing as deciding how many pairs there are. So for my A to the 30th, If I take that 30 and I divide it by 2, that tells me that there will be 15 pairs. Exactly 15 pairs. So 15 A's that need to get pulled out in front of that square root symbol. So I'm going to have A to the 15th sitting out in front of that square root symbol. Okay, if I do the same thing with my B's to the 25th, so if I do B to the 25th and I divide that by 2, now this is where things get a little bit tricky. Oftentimes my students will say, well, I can't divide it by 2. Well, you can. You just get a fraction or decimal, right? But remember way back when, right? What this really tells us is that there are 12 pairs with a remainder of 1. So there are 12 pairs, which gives us, right, there were 24 that went into 12 pairs, and there's one little lonely one left over, which tells us that there are 12 pairs that can be pulled out in front, and there is one that is left over on the inside. So when you're really dividing this and you see that maybe like 12.5 show up on your calculator, right, that 12.5 is really saying that there's 12 pairs and that there's one left over. 1/2 is 1 out of 2. There's that one remaining that needs to stay inside the square root. Number 5. Right, so we have a 2, a 2, a 2, and a 5. And then we have W to the 16th. And you might go, yep, no way do I want to write down that W 16 times. So what I sort of do, right, these are all really my at least coefficient numbers. Inside my square root, I find my pairs. So I know I need a 2 to come outside, and then I just leave some space. And I have a 10 left over on the inside. And then I go to my W to the 16th. I say, okay, I need to take that 16 and divide it by 2, which gives me an 8. So I know that there are going to be 8 pairs that come out in front, and there are none left over, so there's nothing else inside that square root. So 2W to the 8th square root 10. Then if we look at example number 6, now example number 6 has something sitting outside in front of it. Right, we introduced this concept as well yesterday, but when there's something sitting in front, it functions just like a coefficient, right? That's really multiplying. So we'd say 3h times the square root of 12h squared. So since this is being multiplied, right, we're not worried about that right now. Our first objective is to get this 12h squared simplified. So we're going to start prime factoring. Now, maybe you decide I could just divide that by 2 and get 1, or maybe you're like, because there's not that many of them, I just want to stick to what we've been doing, and I want to list my pairs. Either way is fine. Okay, so we find our pairs. We know that a 2h is coming out in front, and a 3 is left over on the inside. However, remember that is not our final answer because there was already a 3h sitting out in front that we were multiplying by, so that 3h is still out there. When we multiply, we add exponents. So 3 times 2 is 6. Those both have a 1, so 6h squared, square root 3. Now, there is one piece here that I want to sort of point out, and you'll notice this is in a separate box because I wouldn't say that this is something we're heavily assessing on or something that's the most essential skill, but I do want you to understand this. Everything that we've been doing with simplifying is based on the concept that we are assuming that the variable is going to give us an outcome of a positive number. And that doesn't always happen. Right? So sometimes when we have, like, for example, this, if b is equal to -2, we really would end up with a no real solution. But we don't know that, right? Because we don't know what value b is. So we can't really decide that unless we know more. So one of the pieces that I want to make sure we're really clear on is in what ways something might become positive or negative. So this is a piece that we've struggled with in the past of how we use our calculator if we wanted to use it for help, or how we even think that process through to start with. And that is, what do these parentheses tell us versus where the negative location is? So remember, parentheses tell us to do that first. So we would take whatever number is inside here and we would square it first. And if we think about it, a number squared, whether that number is positive or negative, is always going to end up as a positive outcome, right? So if x was -7, -7 times -7 would be positive 49. -5 times -5 would be positive 25. Okay, so whatever number we're getting out of this piece squared is always going to be a positive number. Okay, but then the next thing we would do is worry about that negative sign. So that would be our second piece, right? Our second piece then says to make it negative. So if we take any positive number and we put a negative in front of it, we then end up with a negative answer. Okay, so now we're getting a negative number out, and if we're taking the square root of a negative number, we already know that we would say that this is a no real solution. Now, the problem is that the students are then tempted, they get to this problem and go, well, then that must be a no real solution as well, but that's not the case, right? Because in this solution, we're taking a number, and we need to do the negative first. Now remember that negative is really the same thing as the opposite. We're changing the sign. Because if it was -4 and I'm taking the negative of -4, it becomes +4. And if it was 6 and I'm taking the negative of it, it would become -6. Okay, so at this point, we could have a positive or a negative. But once we have that, the next thing that we are going to do is then we are going to square it. Okay, so if we square a negative number, a negative times a negative is a positive. A positive times a positive is a positive. So when we square a number, it's always positive. Okay, which means that this one would have a solution that we could get out of it. Now, we're not going to talk about how to simplify and do all those other pieces with negatives in different locations, but I don't want you to just assume that just like that very blanket idea we've sort of been talking about, right? If there's a negative, it's a no real solution. Variables sort of make that a little bit different, and we need to think in that a little bit deeper with our order of operations and what types of numbers we may have plugged in to start with.